Imagine a moment when the stability of our solar system is shattered, an unimaginable scenario where the sun's gravity fails, sending planets and celestial bodies spiraling into the vastness of space. This thought experiment opens a gateway to fascinating physics, cosmic chaos, and the potential fate of our planet Earth and its neighboring worlds. To grasp the implications of the sun's gravity failing, let's first revisit the concept of gravity itself. Gravity is the force that pulls objects toward each other. In our solar system, the sun, which is a massive ball of hot plasma, exerts a gravitational pull that keeps planets like Earth, Mars, and Jupiter in their respective orbits. This gravitational force is a result of the sun's immense mass. It has over 99% of the solar system's total mass. The planets orbit the sun due to this gravitational pull, which balances their natural tendency to drift away into space because of their inertia, their motion in a straight line. This balance creates stable orbits, allowing life to thrive on Earth as we experience predictable seasons and climates. Now let's imagine that one day, the sun's gravity simply ceases to exist. This could happen, hypothetically, if the sun were to become a black hole without the necessary mass to create the same gravitational effects. While this scenario is scientifically impossible, given our understanding of stellar evolution, it serves as a powerful thought experiment. The immediate consequence of the sun's gravity failing would be that all planets, moons, asteroids, and comets would begin to drift away from their orbits. Earth, which is currently held in a stable orbit approximately 93 million miles from the sun, would no longer be tethered. Instead of a circular path around the sun, Earth would continue on its tangent, hurtling through space. Some planets may collide with each other as they drift apart or change their trajectories. For instance, the gravitational influences of the larger planets like Jupiter could affect the paths of smaller bodies in the solar system, potentially leading to catastrophic collisions. What happens to Earth? With no sun to provide warmth and light, Earth would face drastic temperature drops. Without the sun's energy, photosynthesis would stop, disrupting the food chain. Within a week, temperatures would begin to plummet. Initially, the surface would freeze, but as time passes, the atmosphere would also cool. Eventually, the planet could become a frozen wasteland. As temperatures fall, Earth's atmosphere would undergo radical changes. Water vapor would condense and fall as ice, and without the sun's heat to maintain atmospheric pressure, the atmosphere could eventually dissipate into space. Life, as we know it, would face extinction. Interplanetary chaos. Each planet would drift into a unique trajectory based on its initial velocity and position in the solar system. The outer planets like Uranus and Neptune, further from the sun, may end up drifting into deeper space or potentially colliding with other celestial objects. The asteroid belt between Mars and Jupiter would also experience instability. Without the gravitational influence of the sun, asteroids could collide with each other or be pulled into the orbits of planets, leading to a higher risk of impact events. The larger cosmic picture. As planets drift away from the sun, they might find themselves in interstellar space, the vast region between stars. In this cold and dark environment, planets would be completely isolated. The darkness of space would become a backdrop to this desolate journey. The frozen remnants of Earth and other planets would become uninhabitable. Any remaining water would freeze solid, and the atmosphere would be lost to the void. Without a heat source, planets would become cold, lifeless rocks adrift in space. The solar system would be left with a sun that no longer has its planets, essentially becoming a wandering star in the galaxy. The remnants of the solar system would consist of rogue planets, asteroids, and comets scattered throughout the Milky Way. Over millions of years, these rogue planets could collide with other celestial bodies or be captured by the gravity of nearby stars, potentially leading to new solar systems forming. Humanity, too, would face extinction in this scenario. The sudden loss of sunlight would endanger all life forms that depend on the sun for energy. As ecosystems collapse, people would have to find shelter, food, and warmth. The struggle for survival in a frozen world would be monumental. Some might wonder if humanity could escape to another celestial body. Mars, with its proximity to Earth, could have been a target for colonization. However, without the sun, Mars would also suffer. The chances of finding another habitable planet in the vastness of space would be exceedingly slim. Over billions of years, the remnants of the solar system would continue to drift through the galaxy. While life as we know it would have ended, the elements that once made up Earth and other planets would still exist. They would continue to combine and break apart, cycling through the cosmos. Eventually, in the cosmic scale of time, the matter from our former solar system might become part of new stars and planets. The remnants of our solar system could contribute to the birth of new celestial bodies, continuing the cycle of cosmic evolution. This scenario invites us to reflect on our place in the universe. It highlights the fragility of life and the importance of the sun in sustaining our existence. It serves as a reminder of the vastness of space and the potential for both creation and destruction within the cosmos. It prompts us to think about the future of humanity and the importance of scientific advancement. Understanding the forces that govern our solar system is crucial for predicting future changes and protecting life on Earth. In this hypothetical scenario of the sun's gravity failing, the consequences are far-reaching and catastrophic. From the immediate chaos of drifting planets to the long-term effects on the solar system and potential extinction of life on Earth, the consequences are daunting. However, such a thought experiment also invites contemplation about our cosmic existence, the delicate balance of forces that allow life to thrive, and the infinite possibilities that the universe holds. Understanding these dynamics reinforces the importance of space exploration and the pursuit of knowledge about our solar system and beyond. The more we learn, the better equipped we are to appreciate and perhaps one day mitigate the cosmic risks that could threaten life on our beautiful planet.